Hello people, in this video we take up various arithmetic operations applicable on different number systems. So first number system that we are going to take is binary. Okay, so first arithmetic operation that I am taking is addition. Okay, so we all know that in binary there are only two symbols which are 0 and 1. We're using only two symbols in the binary number system. So we're just looking at elementary addition first. You know this maybe, but we're just revising it. 0 plus 0 is going to be 0. 0 plus 1 is 1. 1 plus 1. See, 1 plus 1 is 2, we know, but 2 is not a valid symbol in binary, and 2 can be represented as 1 0 in binary. So I'm writing it as 1 0. Similarly, 1 plus 1 plus 1, which is 3. But since 3 is not a valid symbol in binary, we represent it as 1 1. Okay. Also, you know about the subtraction. Zero minus 0 is going to be 0. 1 minus 1 is going to be 0. 1 minus 0 is going to be 1. But 0 minus 1 is going to be 1 with a borrow of 1. Now what does this mean? You were supposed to subtract 1 from nothing. Okay, so you borrowed something. See, this is something like this. You had to subtract 1 from 0, which was not possible. So maybe from somewhere here were a few numbers. I borrowed. Okay, I got a 1 here. Fine. So this 1 would be read as 2 since it is coming from a bit from the right. This is coming from right, and you know, just see this. The LSB in binary number system represents 1. Next digit represents 2, then 4. So, and so on. So if you are going to borrow this, it represents 2. The same way as you take a borrow in the decimal number system and you get 10. Same way, because it has base 10. So if you borrow a number in a binary number system, it represents 2. So the value for this 1 is going to be 2. And when you subtract 1 from 2, the answer is going to be 1. Of course, with the borrow of 1. Fine. So let us look at one example now. Suppose you're given a question 1 1 1 0 1 and you have to add 1 0 1 1 1. Let's quickly look at what is the answer going to be. Start from the LSB. 1 plus 1 is going to be 2. 2 is not a valid symbol, so we write it as 1 0. We cannot write it together, so 0 comes here and 1 is the carry here. Again you have 1 plus 0 plus 1, which is going to be 2. Again you do the same thing. Now you have got 1 plus 1 plus 1, which is 3. 3 can be represented as 1 and 1 you get as carry. Now 1 plus 1 is going to be 2, which is again 0 and 1. Again you have got 1 plus 1 plus 1, which is 3. So 1 comes here and an additional 1 has come here. What will you call this? This is called as carry. And this is your required sum. Fine. Now we are going to take up one problem of subtraction. You are given 1 1 0 1 0 and you have to subtract 1 0 1 0 1 from this. Okay, again start from the LSB. When you try to subtract 1 from 0, you are unable to do it. So I am taking a borrow. If I take a borrow, I get a 2 here, right? And this one cancels, this becomes 0. So when you subtract 1 from 2, you get 1. Now you come here, you have to subtract 0 from 0. Here you've given borrow, right? So it becomes 0. 0 from 0 is 0. Now again it is not possible to subtract 0 from 1. So I am again going to take a borrow. 2 comes here. 1 from 2 is 1. Again 0 from 0 is 0. And 1 from 1 is 0. So this is going to be the final answer. Okay, so one more thing, in binary we can also take up multiplication. In other number systems, taking multiplication would not be so easy. So, but in the case of binary, we can look at multiplication also. Let us look at it with one example. Suppose you are given 1010 and you have to multiply it with 1101. In other number systems, what are you going to do is you have to convert the numbers into decimal number system, multiply them because you're comfortable with multiplication in decimal, right? And then you convert them back into the required number system. But in binary number system, you can look at it directly. Just follow the procedure, the conventional normal procedure that you're following. We multiply this complete number with the LSB of this number. So what do you get? You get 1010. Then you put a cross here and multiply the complete number with 0. You get 0. Then you put 2 crosses here and repeat the same thing. Multiply the complete number with 1. So you get 0101. Then we put 3 cross and again multiply. So you get 1010. Now you have to simply add. You remember the procedure, right? We simply add. So what are you going to get at the LSB? You get 0. Then 1 plus 0 is going to be 1. 0 plus 0 plus 0 is 0. 1 plus 0 plus 1 plus 0. This is 2. 2 cannot be represented as a single symbol. So I am writing it as 0 and I am taking 1 here. Again you have got 1 plus 1, 2. So again I write 0 here and I take 1 here. Again this becomes 0 and 1. Again 0 and 1. Okay, one thing that you can note here is the numbers that I multiplied had 4 bits. These were 4 bits each. And the result that you have got, it's got 8 bits. It's got 8 bits. So what can you note? What is a thing that you can note? If you multiply two numbers with m and n bits respectively, that is, if you are having two numbers to multiply, one is having m bits and the other is having n bits, then the result is going to have this will be applicable always. The result is going to have m plus n bits. Okay, that is the addition of both. Fine. Let us look at one more example of multiplication in binary. Suppose you are given to multiply 1111 with 1111. So you start conventionally. What are you going to do? You multiply the LSB of this number with the first number. So what are you going to get? You get 1111. Then you shift and multiply the second digit from the right with the complete number. So you get 1111 again. Then you shift 2 times and multiply. Then you shift 3 times and multiply. You know this procedure, right? This is simple. I think everybody would have reached till here. Now what creates the problem here is that how do you add? How do you add all these numbers? You're supposed to add all these, right? How do you do that? Let's start with the LSB. Since this one, there's only 1 here, right? So it comes up straight and you write a 1 here. Now look at the next digit. This is 1 plus 1. What is 1 plus 1 going to be? It's 2. But how do you represent 2 in binary? You represent it as 1 and 0. So only this comes up in the answer and this 1 goes as carry. So you get a 0 here and 1 comes up as a carry in this case. So now you've got 1 plus 1 2 plus 1 3 plus 1 4. Now how do you represent 4 in binary? Represented as 100. So only this digit comes up here. And where does this 10 go? This goes as carry to the next set of numbers. Okay, this is the thing that you have to note here. Only the LSB of any result is going to show up in the result, okay, in the answer, and rest all the digits are going to be carried to the next bit. Fine. So now how do you read this 10 as 1010? See this 10. How do you read it? The weight of this bit is 1 and the weight of this bit is 2. So in binary 10 means 2. Fine. So you read it as 2 only. 2 plus 1 is going to be 3, plus 1 4, plus 1 5, plus 1 6. Now how do you represent 6? It's 1 1 0. Same thing applies here. You're only going to write 0 in the answer, and this 1 1 is going to be the carry for the next numbers. So 1 1 comes here. Similarly, as you read 1 0 as 2, you're going to read 1 1 as 3. So you've got 3 already, plus 1 4, plus 1 5, plus 1 6. Do the same thing again. Write 0 0 here and 1 1 comes here. Now 3 plus 1 4 plus 1 5. 5 is 1 0 1, right? Take the units digit, write it here, and these two digits are taken as carry. Now this is 2, 1 0 is 2, plus 1 3. So you get 1 1. Okay, also count the number of bits. Both these digits had 4 bits each. And see, in the result you've got 8 bits. So the rule that we just learned is also applicable here. Okay.